Hi, I'm Matt from Group 39 and we chose problem 4, the time of death estimation. So the situation was that a person has died in a hotel room at a steady 21 degrees. That steady 21 degrees is because there's an aircon there. And the person has died sometime before midnight with their living temperature being 37 degrees Celsius. So an inspector arrived at midnight, the body being 27 degrees on arrival, and when she left at 2 a.m. the body was 25 degrees. So this can be represented graphically with this chart here. At time is equal to 0, the body is 37 degrees Celsius. 12 hours later at midnight, the body is 27 degrees Celsius here. And 2 hours after that, at 2 a.m., the body is 25 degrees Celsius. The temperature continues to decrease towards the horizontal asymptote of 21 degrees Celsius. So to solve this, we can use Newton's law of cooling, which states that the change in temperature with respect to time of a body is proportional or equal to negative k T minus S. So it's proportional to the difference between the temperature and the temperature of the body and the temperature of the surroundings, or it's equal to k times T minus S, where k could have been negative, but it just makes more sense conceptually to have the negative sign out the front. And we can solve this via separation. So if we go dt over T minus S is equal to negative k d small t. Taking the integral of both sides, we'll end up getting ln of the absolute value of t minus s is equal to negative kt. We've got constants from both integrations, so we can consolidate them into c little c, which is the consolidated constant. So then we can take the exponent of both sides to get absolute value of t minus s is equal to negative kt plus, is equal to e to the power of negative kt plus cc. So value of t minus s is equal to e to the cc, e to the negative kt. And then we can make this section here into a new constant. There's no variables in it, so that's c e to the negative kt. So then we've still got this absolute value sign, and that's the general solution, kind of, because the temperature could be either above or below the room temperature. But because we know our temperature is above the room temperature, T is greater than S, we'll know that this is always positive, so we don't need the absolute value sign, which will mean we can make this T minus S equal to C e to the negative kt, take the S over, plus S, and because they've given us S, the general solution is going to be C e to the negative kt plus 21. Okay, so that's our general solution, and we're going to try and find the constants here. So to do that, we'll employ a few different times and temperatures here. So at t is equal to 0, which is the time of death, we know that the body is 37 degrees, which is equal to c times e to the 0, which is 1, so just c. And that will mean that c is equal to 16. At t is equal to tor, which is midnight, the body was 27 degrees, which is equal to c e to the negative k tor plus 21, which means that c e to the negative k tor is equal to, we can sub in c now, right? So 16 e to the negative k tor is equal to 6, and we'll come back to this later. And then at t is equal to tor plus 2, we're going to end up getting 25 is equal to 16 e to the negative k torr times e to the negative 2k. And we know from up here, this section here is equal to 6, so 25. Oh, sorry, this is plus 21. Means 4 is equal to 6 e to the negative 2k. And if we rearrange and take the ln of both sides, we're going to end up getting negative 2k is equal to ln 2 on 3. So k is equal to negative a half ln 2 on 3. Okay, so get some more space here. We'll be able to find the value of torr now that we've got all the constants. So our specific solution, actually sorry, we can bypass the specific solution because we've got this expression with respect to torr, and now that we've got k we can solve it. So we've got 16e to the negative, so that would be positive, half ln 2 on 3 is equal to 6. And just put our torr in there. So if we rearrange and take the ln of this, we're going to end up getting ln of 3 on 8 is equal to half ln of 2 on 3 torr, which allows us to get this with respect to torr. So torr is equal to 2 ln 3 on 8 divided by ln of 2 on 3, which means that torr is equal to 3.838, which is roughly equal to 4 hours and 50 minutes, which makes the time of death equal to around 7:10 p.m. Get it?